20, 25 odds. Okay. Okay, here we go. All right, guys. This is not a bad lesson. It's a little too much talk for me, but it's actually a fairly easy lesson for you. What you're going to do, I don't know why I got all those blue on here, but what you're going to do today is graph.
That's fine.
You're going to graph inequalities, but you have been graphing this for the last 2-3 years. You have been graphing what? Equations. You have always been graphing something that has this symbol, an equal sign. Okay, well now you're going to graph inequality. Yes, sir. So right in front of you, like that big pile. Huge pile, right? Go to 280. Okay, so what are inequalities? What's the difference?
They don't have
Less than, comma, less than or equal, comma, greater than or what? Equal. That's what you're doing today. Okay, that's it. Now let me show you how easy it really is. I'm not going to read this stuff to you. I'm just going to say, let's just do a problem. Okay? Y is greater than 1/2 x plus 2. Sorry, I jumped the gun on you. I jumped the gun. Let's do this. Take that out. Put this in. Put an equal sign in. You just think of it as an equal sign all the time. If I asked you to graph that equation, what would you do?
Draw the line.
Draw the line.
Go up to.
Yeah. You'd probably pick up the y-intercept, wouldn't you?
Yeah.
And the y-intercept's back here, up 2. Okay, then you do what?
Up 1 over 2.
This number right here tells you the slope, up 1 over what? 2. So there you go. And then you do it again, right? And you'd be over at about 4, I suppose, right? So there's your line. Okay, there it goes. Now, everything on the line, all these points on the line, this is 4, comma, well, that's actually 4, 4, isn't it? This one's actually what? 2, 3. Okay, these points that fall on the line, they actually form the line. But when you look at these ordered pairs, 2, 3, 4, 4, what are they when it comes to this equation?
3, 4.
This is x, this is y. But the reason these points fall on the line is because these points make this equation true. That's why. Now, when you say they make it true, you're saying this. This must be a what? Solution. Okay? 4, 4 is a solution to this equation because it falls on the line. Let me just test it out. 1/2 of 4. And then what do you...
It would be 3, 4.
What?
It would be 3, 4. Because the slope's up 1 over 2.
I think it's right. This is right, isn't it? I think it is.
No.
Put 4 in for x, put 4 in for y. Is this going to be true?
Yeah.
Okay, what is 1/2 of 4?
Oh, no,
2 plus 2 is 4. So 4 equals 4. True or false?
True.
The second you say this point is true, you have a what? You have a solution. So every solution to that equation is a point on the line. That's why there's a million solutions. But here's what's going to happen today. Today you're going to get this. Today you're going to get 1/2 x plus 2 is, and then we'll throw this symbol at you. Greater than or equal to 1/2 x plus 2. What's the difference?
There's no solution.
What?
There's no solution.
There's no solution?
Anything above the line.
Anything above the line works?
Or on the line.
Or on the line works. Okay, that's what always want to say Luke, but I mean it's Eric, right? Okay, Eric says it's above the line. Everything above the line works or on the line works. Is he right?
Yeah.
Should we try a point? Okay, let's go above the line. How about this one right here? What's this point right here?
4.
No, no.
0, 4.
0, comma 4. So you put 0 in, right? Half of 0 plus 2. And what would you put in for y? 4. I'll put a 4 here. Is this true? Is 4 greater than that? Oh, by the way, this is just 0.
Mm-hmm.
So is 4 greater than 2?
Mm-hmm.
So is Eric right? This makes it true. This is a yes. So you know what? This works. So does this. So does this. So does this. So what do we do? If all these work over here, what do we do? We're shading today. So what does it come down to? It comes down to this. Can you graph a line? Can you graph a parabola? Can you graph a V? And then can you shade what? The correct side. There's two sides. It's either above the graph or it's below the graph. In this situation, it was above. Now, how did you know it was above?
Because it's greater.
Oh, he's reading the sign greater. Greater means above the graph. Is he right? He is right as long as the inequality is solved for what letter? Y. If it's in standard form, can you do that? Nope. Now here's another thing we do in algebra. We test points. And the easiest point to test, look at all these points. I tested 0, 4. That's not the easiest point.
0, 0.
0, 0. This is what I'm going to keep telling you guys. Test that point. Why would I tell you to test 0, 0?
One's easier to multiply than 0.
Yeah, you put a 0 in, it's easy to add 0, it's easy to multiply by 0, it's easy to divide by 0. You can do many things with 0 in your head. You don't need your calculator. Try that point. Oh, by the way, if we would have tried that point, would it have worked? No. You know what? This point is not true. It's what?
False.
So if you find it false, where do you shade?
Opposite of it.
The opposite side. Okay, good. I think you got it. That's the whole lesson. It really is. Should we go?
Yes.
Yep. All right, not reading this to you. Okay, so we're starting here. A linear inequality is an inequality in two variables whose graph is a region of the coordinate plane bounded by a line. Bounded? This is the boundary line. We call that the boundary line, the red one. Sometimes the boundary lines are solid. Sometimes the boundary lines are broken. Okay? The line is the boundary of the graph. The boundary separates the coordinate plane into two half planes, one of which consists of the solutions, the side we're going to shade. The solutions are the side we shade. Now looking at this, what's not a solution? The side that's not shaded. What is a solution? The side that is shaded. And anything on the line. What about this broken line? It's not a solution. Broken lines have no solutions on them. The shaded side is the solution. Okay? All right. Keep going. To determine which half plane to shade, pick a what point?
Test point.
Test point. That is not on the line, the boundary line. Check whether the point satisfies the inequality. If it does, shade the half plane that includes the test point. If not, shade the other half plane. What is the easiest point to shade?
0, 0.
The origin, 0, 0, is usually an easy test point as long as it is not on the boundary line. So you can test 0, 0 anytime you want. Anytime. Unless what?
It's on the boundary line.
It's on the line. If 0, 0 is on the line, how are you going to test it? It's not over here. It's not over there. It's on the line. You can't test it. So if you can't test 0, 0, what would you test?
1, 0.
1, 0. 1, 1. 0, negative. Something easy. 1 and zeros, okay? All right. Okay. This is what Eric was telling you. I don't know if you know this, but Eric said, when the inequality is what?
Solve for y.
Okay, when it's already solved for y, you guys don't really have to do a test point, if you can remember this. less than or equal is shaded where? Below the line, okay? Now, the symbol less than is broken line. The symbol less than or equal is solid. So what's the big kicker here? What's going to determine if it's solid or broken? The equal
What's
sign.
equal to or not?
If you have an equal sign, it's solid. If you don't have an equal sign, it's broken. Okay? Greater than, shade where? Above. Greater than or equal, shade where? Above. I mean, that's how easy it is. Broken when there's no equal, and solid when there is an equal. Okay? Again, Mrs. McWilliams and Salentine and all your Algebra 1 teachers, they hammered that in your head. Do you remember this? I hope so. Okay. All right, guys, quick. Circle the inequalities. Circle the inequalities that have dashed boundary lines. Go ahead and circle. There's four to pick from.
Are you recording?
Yep, that's recording. Okay, tell me. First and last. First and last are broken boundary lines, or broken lines, okay? Then it says
First two.
solid boundary lines. Which ones would be solid? Anything with what?
The line there.
An equal sign. If it's got an equal sign, it's solid. Without an equal sign, it's broken, okay? All right, next. You must take this equation and graph it, but this equation's wrong, so you have to help me out. What's it really saying? I can't. Mine was wrong.
Y greater than or equal to -2x.
Negative 2x plus 1? Okay. All right, guys, go for it. I don't have to show you how to do this. You know how to do this. Okay, a couple questions you should ask yourself when you start is right here. Is the line going to be solid or dashed? Solid. Because it's got an equal. Okay. Here it says, does the test point 0, 0 satisfy or does not satisfy? I wouldn't do it yet. I would graph the line first. How do you graph that line? Where on the y-axis? 1. Slope is down 2, right 1, down 2, right 1, down 2, right 1. You told me it is solid. There it is. So anything on the solid line works or doesn't work? Works. Okay. Where is 0, 0? Right here. 0, 0 actually falls where? Under the line. Okay, check it out. Does 0, 0 work? Put 0 in here. Put 0 in for x. Well, that says 0 is greater than what? 1. Is 0 greater than 1? No. This is no. Not a solution. So where do we shade? Must be on the other side, right? So you should shade the upper right. So go ahead, give me a solution, not on the line, in the region. 4, 3, 1, 1. Let's see here. Here's 0, 0. 4, 3, right here. 1, 1, right here. Okay. Did those 2 points, do they fall on the shaded side?
Yes.
Yeah, they would. How about negative 10, 0?
No.
There, negative 10, 0. No, it doesn't work. You can try it. It won't work though. Okay. All right. I think I'm done there. Oh, I didn't answer this. Does not satisfy. And then the last question was shade above or below the graph?
But
Above. Okay. All right, next. Next. Okay, I can't see this one. Y is what?
y is greater than 3x minus 1.
3x minus 1. Gotcha. Okay. All right, go ahead. Graph it. Graph the boundary line, okay. More or less, just get a graph, okay. Start at negative 1. Slope is what?
3,
3 over
1.
1. Rise 3, right 1, rise 3, right 1. Keep it going. Okay, question. Is it solid or is it dashed?
Yeah.
Okay, dash, because there's no equal sign. Okay, so here I go. So there it goes. Okay, now, here's the hard part. I was a little sloppy. Is 0, 0 above the line or is it below the line? It's above, okay. So it is above. Well, that's hard to see, but it is above. So you checked it out, I hope. You put 0 in for y, you put 0 in for x. 0 is greater than 3 times 0 plus, no, minus 1.
Yes, it works.
Did I talk about Pac-Man? I can't remember.
No, you didn't.
I didn't. But if you have a hard time reading symbols in math, like less than greater than, just remember Pac-Man eats what?
Ghosts.
Eats what?
Ghosts.
Those little white dots.
But he eats the bigger number. So you say 0 is what?
Greater.
Greater. That helps you. 0 is greater than negative 1. Is that true or false?
True.
That's true. If you're going to say true to 0, 0, then this point is true. It works. If it's true, so is this one, and this one, and this one. You should say shade, the upper left side, upper left. Okay. Good? Questions? Raise your hand, Questions? Turn the page. Keep going. Guys, you know how to graph. I'm not surprising you, so just keep going, graph. Get the next one.
2x minus 3y.
Okay, one second. I don't have this one. 2x what?
Minus 3y is greater than 6.
Greater than 6. Okay, thank you. You know, for a class of 25 that already knows how to graph linear functions, only 3 of you had a line. I just went back and forth quick. Only 3 of you had a line on your paper. That's not many. You're either stuck or I don't know what's going on. You don't trust yourself. How did you do it? You solve for y. You put it in slope-intercept form, right? Okay, so if I go solving for y, okay, what's that going to be over there?
Negative.
Minus 2x, out with the 2x, minus 2x, right?
I made everything up now.
Okay, now negative 3y is greater than, I would put the 2x term first. I put the plus 6 second, what I would have done. Okay? Now what? Divide by negative 3. All 3 terms get divided by negative 3. Negative makes positive, 3's are out. So you get your y. Negative makes positive 2/3. Next. 6 divided by negative 3.
-2.
Do you know why I left that blank? Is what? You got to turn it the other way. You got to flip the inequality. What did Mrs. McWilliams or Salentine or whoever tell you? When you divide inequalities by negative numbers, flip the sign. You got to go the other way. The sign goes this way now. Anytime you divide by negatives or you multiply by negatives, you flip the sign. Did you guys remember that?
No.
Okay. But do you remember? Oh yeah, that's what they said back in 9th grade. Do you remember that?
Yeah.
Yeah. Okay. Now it came back. All right. Let's graph. Ready? Where do I start? Negative 2 right here. Okay. Where do I go?
Up 2 over 3.
Up 2 over 3. Okay. Up 2 right 3. Up 2 right 3. Keep going. Keep going. Keep going. Okay. Solid. Broken. What do you think?
Broken.
It's broken. This one's broken. Okay, so broken, this one. Okay? So anything on the broken line works or doesn't work? Doesn't work. Okay, let's figure out what side of the line has all the solutions. Let's try what? 0, 0. All right. Where do you want me to put 0, 0? Here? Or here? The beginning? Here?
There.
Bottom? Okay. All right, I'll do bottom. 0 for this one, and 0 for this one would give me 0 is less than what?
Negative 2.
Is 0 less than negative 2?
No.
No, it's actually greater. This is no. No. False. Well, where are all the points that make it true then?
Below.
Below. Okay. Good? Hey, quick question. Anybody out there not graph it that way? Did anybody choose to do it a different way? You guys solved for y, you put a slope intercept form. Did you by chance look at that problem and say, that's in standard form? I can get the xy intercepts? Not one person did xy intercepts? Okay, guys, I gotta tell you a secret. That is so easy. Watch this. Watch how easy this is. This problem up here, I kind of have to erase it now because I got a mess. Okay, here we go. It was 2x what?
2x minus 3.
Greater than 6? Okay, watch this. All that time you took, I could have just done this. If I want the x-intercept, I know y is 0. If I want the y-intercept, I know x is 0. So watch how quick this goes. Put 0 in here, which would wipe this term out, correct?
Mm.
Cover it up. What does it say now? 2x, pretend it says what? Equals 6. What's the answer?
3.
Divide by 2.
X is 3.
3. Okay, let's do this. Put it here. Cover it up. It's gone. Negative 3y equals 6.
Negative 2.
That's negative 2. Look. 0, negative 2, right here. 3, 0, right here. I could have done that, and I just went broken. That's how quick I could have done it. It's crazy. Okay, when does that work really nice? Really nice when you look at the 6 and you go, wait a minute, 6 is divisible by 3 and 6 is divisible by 2. I can do these in my head like that. But instead, you guys all did what? Solve for y. Solve for y. Why'd you do that? Is it easier for you? Or have you been trained? I think you're trained. I really do. I think you're trained. You kind of sometimes have to untrain yourself. Like, there are other ways to do things. Sometimes it's quicker to do it the other way. The reason I'm telling you this is because the next problem, I want you to find x, y intercepts. Okay? Here we go. It's right there. I missed it. There it is. It's a story problem. You ready? Okay, here we go. There's details to pay attention to here. Adrian? Details with your eyes open. Mr. Cummings? Boy, he's out like a light.
No, I'm not.
Okay,
Pretty close.
pretty close. Okay, slap yourself in the face 3 times and you'll wake up, I promise. Okay, and if you can't slap yourself in the face because you're too pretty or something, I'll have Gavin do it, okay? All right, here we go. The map over there shows the number of tickets needed for small and large rides at a fair. Okay, so come on over here. A small ride costs you how many tickets?
3,
3. A large ride?
5,
5. Hey, what do tickets cost?
25.
25 cents. Got it? Okay, here we go. You do not want to spend more than $15 at the fair. Now you got to remember something. This is an inequality section. You don't want to spend more than $15, so what symbol do you think you should use?
Less than or equal to.
Less than or equal to 15. I'll spend 15 or less, but I don't want to go over 15. Okay? Now, here is the kicker. If you can get this in your head, from now till June, this will save you a lot of headaches. Find the question to your story problem, and it's right here. Here's the question mark. How many what?
Small,
How many small or how many what?
large,
Large rides can you ride at the fair for 15 bucks? So you know when I say what's the question? Whatever the question is, that's the 2 variables, x and y. So you decide, what do you want x to be? X will stand for what?
large,
You want small rides or you want large rides?
large.
Large? You okay with large? Okay, a lot of people go, no, I like small because small's first, then large, but whatever. So you said X stands for the number of what?
Larger.
Large rides. Okay, Y would have to stand for what then?
Small.
Number of small rides. Okay, well, here comes the problem. The big thing is, can you do this? Can you write some kind of inequality to match this story? And you know the thing you're looking for is what? How many rides? How many large and how many small rides can I jump on? Okay, well how many large rides can I jump
3.
on? You told me this many. What's that number?
Oh, X.
It's X. And if I say how many large rides can you jump on, you tell me
X.
X. I can jump on this many large rides plus I can jump on how many small?
Why?
Y. Okay. That's almost all problems start like that. X plus Y or something like that. But the problem with this kind of story is X and Y get a value. You jump on that many large rides, what's the value of a large ride? 5 what? 5 tickets. You have to do this, right? What if you jumped on 2 large rides? 2 times 5 is what? 10 tickets. 3 large rides. 3 times 5.
50.
See, it works. It works. Okay. What about this Y?
3.
3 tickets for the small, right? So you're spending all your tickets on these large and small rides, and over there, usually, it's going to be an equal sign. Usually, but it's not. How many? What am I going to put over there?
25. 50.
15.
15.
That would be less than.
Okay, wait a minute. Are you sure it's 15? Tickets plus more tickets should equal total tickets. Tickets plus tickets should equal tickets.
Oh, so it'd be 25 times 6.
Did anybody read this?
You
You can buy how many tickets?
60 tickets for 15.
60 tickets for 15 bucks. They were only 25 cents a piece. So guess what you're gonna put over there? Yeah. Tickets plus more tickets should equal the total tickets. But wait a minute. It's not an equal sign.
It'd be greater or less.
No.
Or less than.
I want to spend $15 or less. Well, $15 is 60 tickets. I want to spend less than 60 tickets or exactly 60 tickets. There it is. I got it. I got the equation. Now, hang on. Did anybody go with money? Did anybody want to do the money one? Did you? What did you do?
I didn't do anything.
You didn't do anything?
I was asking, well, shouldn't we change the
Well,
5 and the
okay.
20 to the ticket
Let's do this.
prices?
Let's do this again. Let's not throw the ticket value on. Let's throw the money value on. A large ride costs you what?
5 tickets.
No. $1.25. If
Oh,
we're gonna,
yeah,
hey,
I know.
if we're going with money, now we're talking $1.25 for large ride. What's the small?
75 cents.
Okay. Now this less than or equal sign's still there. What am I putting here?
15.
Now I can put the 15 for money. This is how much money it costs for large plus how much money it costs for small rides. This is all my money, 15. See, here's the deal. If you use 15, you got to use money plus money. If you use 60, you got to use tickets plus tickets. Now, I personally would go with this equation. How come?
Easier.
No,
No
this
decimals.
No decimals. Yuck. Decimals just don't. Okay, so here we go. Let's graph. This is what we're graphing. 5x plus 3y equals, or is less than or equal to 60. Okay. Now, which method do you think I want you to graph? Solve for y? Or use my hint? Go get your what? Get your xy intercepts. It's so easy. Just do it. Please do it. Okay, anybody put the 0 in for x? Just cover it up with your hand. Cover it up with your finger. Yeah, now it says 3y. 3y equals 60. What's the answer?
20.
20. 0, 20, right? Okay, now let's do the other one. Let's let y be 0. Okay, now. Okay, let y be 0. Cover up the y term. Now it says what? 5x equals 60, or what?
12.
12, 0. Okay, good. Got it? Now, here is another thing about story problems. Many times, listen, many times, negative numbers don't make sense. Do negative numbers make sense in this story problem?
No,
Are you going to jump on -6 rides?
no.
No. Negatives are not coming into play, guys. There's no negatives in this story. So you know what I do when there's no negatives? See that origin? I go down here. I put my origin down in the left corner, lower left corner. This becomes my what?
X.
X-axis. This becomes Y. Okay? All right. And then I label my axes. What's the X-axis stand for? You guys said X equals what?
Large rides.
Yeah. This axis are your large rides, where the y-axis would be your what?
Small rides.
Small rides? Okay. Right? And by me starting in the corner, do you know that I can now get to 20 and 12 pretty easy? 0, 20 would be right there. That's 20. 12, 0 would be right there. I can connect them. Do you know that everything on the line equals what? 60 tickets. anything on that line, you're gonna spend all 60 tickets. Okay, the question becomes, when do I spend less than 60 tickets? Is it shaded above or shaded below?
Below.
Okay, some people just, that just makes sense, but if I try 0, 0, let's plug it in. 0 here, 0 there. 5 times 0, 3 times 0 is 0. So is 0 less than 60?
Yeah.
Yeah. So you would shade below. Why did I not shade below the x-axis to the left of the y-axis? Because of what? If I go down here, or to the left of the y-axis, I'm in the negative zone. Do negative numbers make sense? No, not in this story, probably. Okay. Hey, give me an example of the answer. Just one example. What? Give me one example of a possibility.
One 12 large rays. Or wait, no. Tickets.
One what?
One.
One.
Oh.
Can I go? Hey guys, watch. Can I go on one large ride and one small? Do I have enough money?
Yeah.
Yes, I do. That is a solution. Can I go on, let's say, 10 large rides and one small? Yeah. How about 10 large and 1, 2, 3, 4, 5, 6 small? No. Don't have enough money for that one, but that one you do. Okay, you got that? Okay. Story problems get kind of wicked. All right? Turn page. There it is. We're going to graph that one, and that's probably where we're going to finish. I am going to rewrite this for you so it looks better. Okay? How do you graph something like this? Doesn't this look kind of like it's not ready to graph yet?
Yeah.
What do you got to do?
Yeah, why back?
Yeah, guys, every 12, those last 24 problems I gave you, it always said y equals or f of x equals. You got to get y by itself. So what would be the first thing you'd get rid of up there? The 1. How do you get rid of 1? Subtract it. Okay. Minus 1 out. Minus 1 in the back. So you have this now. Okay? That make sense? Now you got negative y. You want it to be positive. Divide by negative 1. Okay. So divide by negative 1. Divide this term by negative 1. Divide this term by negative 1. Okay. There's only one thing up here that's hard. This makes what?
Why?
Y. This back here, negative 1 divided by negative 1 makes positive 1. That's easy. This is the part that gets a little weird. All you have to do is look at the coefficient, the multiplier, and the multiplier out here is 1. What's 1 divided by negative 1? Negative 1. So the absolute value of x plus 2 has what number in front? Negative 1. Okay. We have graphed this all week. Do you know what to do when you see this? What's inside? What does that say? Left 2. What does this say? Up 1. There's my vertex right there. Now, this number in front is the stretch or the compression. The number 1 is that a stretch or a compression? It's the parent. 1 is the parent. Oh, so don't worry about the 1. What's this negative?
It's upside down.
It's okay. Give me the word though.
Reflection.
Reflection. Reflection. Okay, so it's upside down, like you said, Jim. It's reflected over that side. So here we go. The normal parent for the absolute value goes right 1, up 1. You're going right 1, down 1. The normal parent goes right 2, up 2. You're going right 2, down 2. Hey, do you remember yesterday what I said? This number right here is known as the what of the V? Slope. That's the slope of the V. It's just the slope. So where would you go? Down 1, right 1, down, look at, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. You could just do this forever. That's how easy that number is in front of the V. In front of the absolute value, it's a slope. Now, broken or solid?
Broken.
Okay, broken. Okay. And then, of course, you'd mirror it, right? You would mirror it over here. Is your hand up? Okay.
Isn't the less than sign supposed to be greater than 2 divided by 3?
Oh, he caught me. Did you catch that?
Yeah.
Tyler caught me.
Taylor?
Taylor caught me. Less than should be switched to what? Greater than. This should have been greater. Sorry. Okay. So greater than. Do you guys remember in the very beginning when I said if it's solved for y, greater than means shade where? Above. This is shaded above. But here's the deal. If you don't remember that, can you try 0, 0? Can you put that in? 0 goes in. 0 plus 2 plus 1. Anybody know? Okay, what's 0 plus 2? 2. What's the absolute value of 2?
2.
2, but there's a negative in front of it. 0 is greater than negative 1. Is 0 greater than negative 1? Yeah. So this is true. So let's shade where? Out here. Problem 7, I'm not going to get to it. I just don't have time, and I won't get to it. So we'll deal with number 7 on Monday. It is in your assignment. You got to kind of figure it out on your own. Please remember this: the number in front of the absolute value sign is the slope of the V. Slope of the V. So what's supposed to be on this stool right here? 9 through 29 odds, right there. If you want graph paper tonight, probably for you guys Sunday night, it's over there. Or there is some right here. Some graph paper right here.
Lewis is late.
That's why my card
You put it on there. Yeah, I got it. Alright, okay, from 1929 there.
I got that one.
So do we do those
You just don't know. When you go to your calendar, you're going to read all the problems. It's going to say 19%. Now, you have it? It's going to say, like, do 7, 8, 9, and then it's eventually say 19%.
Oh, okay.
Won't do 1925.
Yes.
Okay.
Every other, I mean, there's still probably about 15 problems a week.
Okay.
So,
I had one. Won't see it, but no. Yeah.
Really, really bad. I just the door.
No, you don't need them. I think that works.
Yes.
This is, that's just the best.
You're right on. I am,
Am I right on?
but there is, no, I am alone, sorry, that's right.
Riley Fulton,
Yep,
can you
that was
please
last
come
time.
to the office?
Um,
Mr. Fulton, to the office.
Hello. Hello.
Hey.
I'll be out of here just like
No
I
problem.
just gotta,
I think we have time.
Oh, feel great. Wanna be there.
I just hit your door.
Oh,